Here I have one of these anti-static mats which I just purchased from eBay. It's from China. Since I can't find my old one, I'm not sure if I still have it anymore. So I thought I'd buy a new one. They're not particularly expensive. Basically it just comes with this rubberized mat with this green layer on it. This should have some sort of very high resistance. The top coating's probably not conductive at all. I'm not sure if we can measure any resistance on this, but I'd say this is just plastic on the top probably anyway. Some of these I think you can measure a bit, but no, it's not actually measuring anything, so maybe it's a fake one, but usually do get a little bit of resistance, I think, but they're basically designed to take away static voltage, which is very high voltage anyway, so it doesn't take a lot of conductivity, and you don't want these to conduct too much if you're working with electrical stuff on them anyway. Looks like it comes with an earth connection for the mat, as well as the static wrist strap, which you put around your wrist obviously to keep yourself, if you're wearing, if you're not wearing synthetic clothing, it's not too much of a risk of static, but if you have anything sort of plasticky clothing or anything like that, there's a good chance it could build up some static as you move around. So you normally put this around your wrist and then connect your body to the mat or to the same earth thing as the mat, so that everything's kept at earth potential and you don't get any voltage building up, which with CMOS ICs and stuff can destroy the junctions in them, some of the FETs and different components. So it never hurts to do this if you're working on any sort of computer gear where you're unplugging like memory modules and stuff, or microprocessors. If you're working on little mobile phones and stuff with a lot of digital circuitry, it's usually best to keep the static under control with one of these things. So this is the wrist strap, conductive plastics and rubber for static control, and EMI shielding. Don't know if it does much shielding. Yeah, this has got a 1 mega ohm resistor building, which is important because you don't want it to be directly connected to the mains earth in a building or something, in case there's some sort of problem. If the wire gets broken off the earth stake or something and then an appliance goes faulty, you can get potentially up to the 240 volts on the earth side of things. Most of them are doing it in Australia back to the neutral, so it's probably not going to happen. It's probably going to blow the breaker anyway, but there's always a potential, so you want to isolate yourself via a high resistance, which will still pass any 1,000 or more volts of static sort of electricity, which is up in the thousands of volts. That'll still go through a 1 mega ohm resistor like it doesn't exist. But if you end up with like your 240 volts or 110 volts wherever you are coming back up the earth line, you definitely don't want that getting into you, because then you'll get to electrocute yourself. So we'll have to check. This earth one might have the same thing. Banana plug, alligator clip. So these actually might have must have a banana plug under. Yeah, it's under the alligator clip. So you've got the clip you can clip onto something, and you've also got a banana plug you can plug into a banana plug socket. I think they do make like a little metal bracket with a couple of banana sockets on it and an earth wire coming out of it, so you can buy that to plug these into. My power supply's actually got an earth terminal on it, which from memory just goes to the chassis and the earth wire through the mains cord, so that already has a banana plug and a binding post. So hopefully I can plug one of these into that via the banana socket and probably clip the clip lead around the other part of the binding post. Now this comes, I assume this clips off. Yeah, so it comes with an earth thing. It looks like it's got these little prongs on it, but it's not attached yet, so obviously the factory expects you to do that. I don't know if you're meant to slide these under or probably bend them up a bit. I think that'll work easier. You could potentially sort of slide them in sideways, but I don't think that's such a good idea. So I reckon if we bend these up and poke it through the mat, normally they just come in one corner. So you just have this little, much like the clasp thing on your pair of jeans or something, a little catch thing, so that you can pull the lead off. So I don't know if we can just poke that through this stuff, how hard this is going to be to... I just really want it in the corner somewhere, and try not to stab it through into my fingers. Oh, it does go through. I'm just pushing a finger either side of each one. I think if we just poke those through and bend them over, should be enough to conduct any electricity and mount this thing properly. Just being careful not to stab yourself. But yeah, if I push it right up in the centre there, and my pliers are going walkabout, but I should be able to just bend that over with a screwdriver or something. I don't know if I should bend them inwards or outwards, probably doesn't matter too much. Just using something hard to press on them. I'm just going to push them all inwards. Not the best design on earth, but that'll do the job. But just push them right in so they can't, you don't grab the corner and stab yourself or something. They're pretty flat to the unit there, so I should be able to just clip this on. And if I remove that, I can plug that into the terminal. It's going to be a little bit annoying with that cable. But I guess I better check. Actually, one thing I better check on this, have they put a resistor? There's nothing on the bag for this bit. Let's check the ohms. Yeah, we've got about a meg. So that's good. So this, you also want this one to be somewhere probably in one of these, the plug or the other bit they've put a resistor. Again, just to isolate yourself in case your mains voltage ever, due to a faulty earth or something, comes through. I'll just check between the power point earth, yeah, and the terminal on my power supply, so that's good. I've got a connection to earth there. So I can just plug that in there, and then we need to get into the static bag and find some scissors. Being careful not to cut the actual lead. It doesn't cut very easy. And yeah, that one comes off as well, although I'll probably leave that one on in this case, but at least we know. Now whether, this does have a metallic part that touches you. Again, I'm going to just double check that that actually is. No, I'm on diode test now. Yeah, just under a meg ohm again. So that just presses that metal part against you, and with a elastic strap to hold it tight against you. So you just wear that, something like that, whatever's on the, it's actually got a clip on it as well, by the look of it, if I can get it to come off. So that can be unclipped as well, which is handy if you want to walk away from the bench and don't want to take the thing off. So you can wear it like that, or the other way around. That might be the best if I do that mounting post there. I can see why it might be easier to have some terminals closer, so I might have to change this later. That's actually pretty fine. It's a little bit stretched there, but I could work with that. And then if you're working on like this colour TV pattern generator that I've got someone's half built on eBay, I want to finish it off. Don't know what that wire is, but now it's very safe to handle this board. That hasn't been tightened up. And yeah, I've got to plug in one more chip as well as make a few connections, but at least this board, this has got all, there's a 74HC series, or even that's CMOS, I think. Another 74HC, so they're low power TTL, so I think they're CMOS as well. I doubt anything on here isn't. And yeah, CD4053 is definitely a CMOS chip. But yeah, that should make it nice and safe. I can solder on here. I don't know how solder resistant this plastic is, but it would be better than working on the carpet, which is just there to protect any equipment I have from getting scratched. I think that'll work out rather well, even with that sort of length. I guess it might be a bit of a hassle if I go to get my soldering iron. I have to stretch it a bit, so I think I'm going to have to run a bit of wire. It's a shame they didn't give us two of these things. You almost got to clip both things onto the actual mat and just had one lead back to earth. Might have been a better way to do it. But yeah, if I maybe do something on the bench here, yeah, that'll give me more freedom if I do something on the front of the bench, I think, with that one. And the other one's fine going backwards out of the way. And that'll save any static build up. It'll just drain through those 1 mega ohm resistors, whatever they were, back down to earth, so you can't build any potential up. so that when you're touching these chips and moving around, even this sort of plastic and stuff and circuit boards moving around could generate a bit of electricity. It'll just drain all that back down to earth potential, and there's no chance of a little high voltage spark somewhere getting in and or potential getting in and damaging one of these chips. I think once you solder a couple of these pins of these chips, they've got diodes to protect them. They're a lot better than they used to be. They used to be very easy to kill, the early CMOS, sort of back in the 80s and stuff. So that should solve that problem. That'd be a handy little bit of work gear to have. You can also get a rubber soldering mat, which I have ordered one as well, so I might have that on top of this just to protect it. Being silicon, it doesn't burn easily, but how sort of static dissipative that is, I'm not sure. It might actually add static, but even that sitting on this mat and with a wrist strap on should be enough if you're touching things, touching with the soldering iron, which is also earthed. That should be enough to keep the potentials pretty low. I'll just double check, but I think the soldering iron should also go to earth. Yep. So the soldering iron tip, that's on my Hakko 926. I think you'll find most soldering stations, because they've got a heating element up the middle of the barrel, which is metal, they need to be earthed. They can't be double insulated. So that should work out alright. Now I've actually got the setup, so I might just put a different earth terminal. Again, you can be pretty safe knowing that there's a high value resistor in these, but it probably wouldn't even hurt to put another one between these if you're going to wire it in into the main sort of thing. So one's I've got through the power supply, so that's directed to earth. I guess it's no worse than having the soldering iron tip touching things that you're working on, and that's also potentially going to get a high voltage on it if something goes wrong. But like I say, the Australian system, because we've got multiply earth neutral, that means if active does hit the earth terminal of some appliance, like something shorts to the case of your washing machine or something, that earth terminal, even if it gets disconnected from the ground, is still connected to neutral. So to basically be, if active touches the metal case and goes down earth and the earth is floating, it'll still short to the neutral, so that'll be like a massive short circuit, which should blow any circuit breaker anyway. But just for safety's sake, other countries have different setups, so it's always best to make sure you get the proper ones with a resistor in them, or add your own resistor, so that you can be safely isolated from earth. Not as far as static electricity is concerned, but as far as any potential high voltages coming back up your earth wire, because most earth stakes are outside the house, and it wouldn't be hard for something to break off or get knocked off. Even really super dry soil and stuff can cause earth potential rise around the earth stake. So it might still trip the breaker eventually, but it might rise up to 30 volts, 60 volts or something before it does, and you don't want to be connected to that. So you always got to think of safety first. But at least this should be a good little mat to do the job. It's a nice size. I think it's around, is it 500 by 300 or something like that. So it's a perfect size for reasonable size circuit boards. You probably wouldn't be able to fit a complete computer motherboard on here necessarily. Modern ones are a bit smaller, so the early ones were quite big. But for a lot of kits, you're not going to be building on a board much bigger than this. So this is pretty perfect for that sort of thing. And if you're plugging in chips into sockets and stuff, always a good idea, even though you should be using an insertion tool that shorts all the pins of the chip together. That's always the best thing to use. You just grab the chip with the metal insertion tool, or plastic anti-static ones, and you should be pretty right. But anyway, that'll solve that problem, and I can finally get back into a bit of kit building without having to worry about blowing up any of the CMOS chips when I'm inserting them. Even though if you do use a proper insertion tool that shorts all the pins together and use that to get them off the foam, the anti-static foam that they come in, and then insert them in the board with that, and then I think you solder the power and the ground pins first, that should be pretty safe. You can even often leave the tool on there, or if you juggle it the right way, you can actually have the tool pushing against the board and solder those two pins, so all the pins are still shorted together while you solder the first couple. But this should always a good thing to have if you're especially doing actual kit building. And with some digital equipment, it certainly doesn't hurt to, because static, supposedly, even if it doesn't kill something straight away, it can do sort of damage to the components that will show up later on, so it'll reduce the reliability or the lifespan of the thing. So it's always a good idea with anything digital to make sure you have this sort of thing handy and have that in your workplace to keep the static down. I think this carpet I got here is actually synthetic stuff, so it's not real good. Really should have wool carpet, because that's again will generate, if you're rubbing around on that, will generate static to some degree. But at least if I'm earthed, I can't really generate any potential at all, no matter what I do, and that should protect everything. Thanks for watching.